So here we're going to talk about simplifying radical expressions. So the first rule we'll talk about is the product rule for radicals. And basically, if they are the same root, like if they're both square roots, both cubed roots, both fourth roots, then you can multiply what's inside. The radicand that we talked about before, you would multiply those inside the root. On the quotient rule, it's the same concept, that if they are the same root, you can split them apart or you can put them back together. Same process. So let's go look at some examples of this. So if we're looking at the square root of 9 times that square root of 4, well, we know that the square root of 9 is 3, square root of 4 is 2, and we end up 3 times 2 is 6. Another way that we could work this exact same problem is to put them underneath one radical. Because they're both square roots, I can put 9 and the 4 inside and multiply them. 9 times 4 is 36, and the square root of 36 is 6. So you can go either way and put them together. In this case, they're both square roots, so that's where you end up with the possibility of going one way or the other. In another situation, they may not be square roots, perfect squares, and so that's where you'll have an issue with not being able to already take the square root. So you want to put them together to see what you can do with it. All right, let's look at another one. If we have the square root of 3 times the square root of 5, this one we can't do individually because they are not perfect squares, but I can put them together inside and I get the square root of 15. That's still not going to break down, that's just your answer. If I have the square root of 21 times the square root of x, I can put those underneath the radical and I get the square root of 21x. In this situation, I have the cubed root of 4 times the cubed root of 2. Because they're both cubed roots, I can do the same thing. I can do the cubed root of 4 times 2, which is the cubed root of 8, and the cubed root of 8 is going to get us 2. We can do the fourth root of 5y squared times the fourth root of 2x cubed. And that gets us the fourth root of 5 times 2, which will get us 10. And then we have an x cubed and a y squared. Order does not matter. We can't do anything to reduce that because we don't have 4 of a kind for any of those. So that is just going to stay the way that it is. All right, let's look at that quotient rule. And we've talked a little bit about the quotient rule before in the last section. We have the square root of 4 over 9, which again we can do like this, or we can do the square root of 4 over the square root of 9, which gets us the square root of 4 is 2 and the square root of 9 is 3. So that would be your answer. You could have just taken it that way, which we talked in the last section. Now for something like this is where it will become more useful to separate them. I can't take the square root of x, but I can do the square root of 16. So when I separate them, then I can simplify the square root of 16 to be 4, but the square root of x is going to stay just the way it is because I can't do anything with it. All right, in this case, we have the square root of 75 over the square root of 3. This one, I can't do anything the way they are, but if I put it back together under the radical, I can take 75 divided by 3, and 75 divided by 3 is 25, and the square root of 25 is 5. So sometimes you're going to want to put them together in the radical so that you can actually simplify it down. All right, what if we have the square root of 25 over 49? We don't actually have to separate it because if they are perfect squares. I can just take the square root of 25, which is 5, over the square root of 49, which is 7. So you don't always have to break it up. When they're that perfect square part, you can just leave it as it is. All right, let's look at another example. If we have the square root of x over 9, we can break this to be the square root of x over the square root of 9. So we still keep the square root of x, but the square root of 9 would be 3. All right, what if we have the fourth root of 3 over 16y to the fourth? We would end up with the fourth root of 3 over the fourth root of 16y to the fourth. Well, the fourth root of 3 will do nothing, but we can take the fourth root of 16, that's 2 times 2 times 2 times 2, and y to the fourth, well, 4 divided by 4 would get us 1, so we end up with the 2y. So now we're going to look at simplifying radicals. So those were our product and quotient rule. And now we're going to look at doing ones that are not necessarily perfect squares and that will reduce. It's just a little bit more effort on them. So if we're given the square root of 50, what we're going to do is factor it down to the prime factorization. Now, I can choose any factors of 50. I can choose 5 times 10 or 2 times 25. It doesn't matter. I'm going to choose 2 times 25, but I could have done 5 and 10. You'll end up with all of the same factors. So here we have 5 times 5. I'm going to just show you I could have done the square root of 50 using our 5 and 10, and here I end up with 2 times 5. I still end up with 1, 2, and 2, 5. So it doesn't matter which factors you choose. What we want to do is rewrite the radical using our factors. So 2 times 5 times 5. No matter which way you did it, you're going to get the same factors. Now we're looking for a group of 2. I hinted at this when we were doing the x's in the last section where we had like x to the 6th. We're looking for a group of 2 because it is a square root. So I can pull the group of 2 out. When I do, I get one number that comes out for the 2, 5s, and then it's the square root of 2 is left over. So this would be your answer. All right, let's look at another example. If we're doing the cubed root of 24, again, it doesn't matter what factors we use. We can do 2 and 12, we can do 3 and 8, 4 and 6. It doesn't matter. I'm going to do 2 and 12. 12 would be 2 times 6, and 6 would be 2 times 3. No matter which way you choose, you'll end up with the same prime factorization. So we have 2 times 2 times 2 times 3, because we're just grabbing the ones at the end of the factor tree. We're looking for a group of 3 because that is the exponent. So a group of 3. That'll get us 2. Oops, I forgot my cube up there. Cubed root of 3. And that would be our final answer. All right, let's look at the square root of 26. So it divides by 2, 2 times 13. Well, it won't go any further, and I have to have a group of 2. So this is just going to be the square root of 26 because it's not going to break down. We could take a decimal approximation, but that's not what we're trying to do on here. All right, let's try the fourth root of 32. So again, we're going to group it with our factors. So you can use any factors. I'm going to do 4 times 8 this time. 4 would be 2 times 2. 8 would be 2 times 4. 4 would be 2 times 2. So I have 1, 2, 3, 4, 5 2's at the end of my trees there. So I'm going to have the fourth root of 2 times 2 times 2 times 2 times 2. And I'm looking for a group of 4 of a kind. I've got 4 2's. The group of 4 will come out. And that'll give me 1 2 on the outside and the fourth root of the 2 that's left over on the inside. And that would be my final answer. All right, let's look at another example. If we have the square root of 25x to the third. So the 25, we're going to do the same way. It's 5 times 5. So we'll have the square root of 5 times 5, and I've got 3 x's. So in this case, I'm looking for groups of 2 because it's a square root. So there's 1, and here's a group of 2 x's. So it'll get me a 5 on the outside, an x on the outside, and there's 1 left over, so that x will be on the inside. And that would be my final answer. All right, let's look at the cubed root of 54, x to the 6th, y to the 8th. So again, 54 we're going to break down. We can break that down to a couple of different ways. I'm going to just go with 2 times 27. This 27 would be 3 times 9. 9 is 3 times 3. So this becomes the cubed root of 2 times 3 times 3 times 3. I have 6 x's, and I have 8 y's. Yep, I got them all. All right, all under our radical. We're looking for groups of 3 of a kind. Here's 3 3's, 3 x's, 3 x's, 3 y's, 3 y's, and then I only have 2. So each one comes on out. So the 3 comes out. I have 2 groups of x's, so that'll get me an x squared. I have 2 groups of y's, so that'll be a y squared, because there's 2 of them. And then I have the cubed root of a 2. All the x's are gone. And then I have a y squared left inside because it's a y times y. And that would be your final answer. All right, let's look at another one. If we have the 4th root of 81z to the 11. So 81 I know is 9 times 9. 9 is 3 times 3, and 3 times 3. So we have the 4th root of 3 times 3 times 3 times 3, and then I have 11 z's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sometimes when I'm doing this, if you notice, I'll put a little break in between the groups of 4, so it makes it easier to circle them. I need 4's of a kind. There's 4 3's, so that'll get me a 3. I have 2 sets of z's, so that's a z times a z, which gets me the z squared. And then in the inside, I still have 3 z's, so that'll be z cubed. And that would be our final answer. All right, so there's different things that we can do to work these problems out. Let's look at a different kind of a problem. So what if we have the cubed root of 48 x to the 4th y to the 8 over the cubed root of 6y squared. So in this case, I want to put this back together. So I'm combining the quotient rule with what we're doing. So this will end up being the cubed root of 48 x to the 4th y to the 8 divided by 6y squared. So when we put this together, 48 divided by 6 will get us 8. Our exponents, because they're being, the x to the 4th is going to just stay put. And our exponents on our y's, because this is down here, it will come up and be subtracted. So 8 minus 2, so that'll get us y to the 6th. Now with that, we can break this down. So 8 would be 2 times 4, and then 2 times 2. So that would get us the cubed root of 2 times 2 times 2. We have 4 x's, and we have 6 y's. So group of 3 of a kind, 3 of a kind, 3 of a kind, and 3 of a kind, because of our cube right there. So we end up with the 2, an x, and we have 2 y's, so that'll get us y squared. cubed root, there's just an x left on the inside. So that would be the final answer on that one.